Hey everyone, so today we're going to be doing distance, rate, and time word problems. So let's start out with number 1. An aircraft carrier made a trip to Guam and back. The trip there took 3 hours and the trip back took 4 hours. It averaged 6 kilometers per hour on the return trip. Find the average speed of the trip there. So first we have to think of our distance, rate, and time formula. So we know that rate times time equals distance. So that's number 1. Number 2 is, to solve these, I like to make a table. So we're gonna make this our rate category times, this will be the time slot, and then it'll equal, and this will be our distances. So this will be the rate for the trip there, the time for the trip there, and the distance for the trip there. This category right over here. So we're gonna call this there, because he's going to Guam and then he'll go back. So this will be our back category. So we just want to fill out the table as much as possible, and then whatever we can't fill out, we'll make a variable. So trip to Guam and back. The trip there took 3 hours. So we know there the time will be 3. Time is in hours also, by the way. And then the trip back took 4 hours, so we'll fill out 4. It averages 6 kilometers per hour on the return trip. So going back, it'll be 6, because that's the rate. Find the average speed of the trip there. Okay, so the one that we don't know is the there. So we're gonna make that x. So the distance there will be 3x. The distance back will be 24. Now let's visualize this. So he's going, let's pretend like this is Guam, and this is the house. So he's going there, and then he's gonna go right back. So what do we know from this? We know that the distances are the exact same. So we know that this distance, the distance there, will be the same as the distance back. So we can make 3x equal to 24. And then we can solve it from there, because we know that x will equal 8. So the average speed of the trip there will be 8 kilometers per hour. All right, so why don't we try another one? A passenger plane made a trip to Las Vegas and back. On the trip there, it flew 432 miles per hour, and on the return trip, it went 480 miles per hour. How long did the trip there take if the return trip took 9 hours? All right, similarly to before, let's make our table. Rate times time equals distance. And then he's going there and he's going back. So there, back. Instead of just writing it fully, I'll just make T and P. And then we'll fill out the table as much as possible like before. So what do we know? The return trip took 9 hours. So back, we'll fill out a 9. How long did the trip take there? So we don't know the time, which is what we want to find. Now, miles per hour we know is a rate. So, and 480 is also a rate. Whenever you see miles per hour, you know that you're talking about a rate, or else it would just be he flew 10 miles. So on the trip there, 432. So we'll fill out 432. 480 we know is for the trip back. So 480. All right, so 432x, and then 480 times 9. So I just suggest a simple calculator, or you could use a graphing. Really, either works. My graphing calculator is all the way far away, so I don't feel like getting it, so I'll just use this one. So 4,320 is what it equals. 480 times 9. All right, so now this problem is similar to before, so we know that both of the distances equal each other. So we can just make 432x equal 4,320. And if you didn't know this, x has to equal 10, but if you did it on the calculator, yeah. So x equals 10. So it'll be 10 hours. That was taken for the trip there. All right, let's try another one. A cattle train left Miami and traveled toward New York. 14 hours later, a diesel train left traveling 45 kilometers per hour in an effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up. What was the train's average speed? So now we're getting a little more into it. The problems are getting a little harder. So why don't we draw a little picture to visualize it? So this will be Miami and travel toward New York. And this will be New York. So this will be the cattle train. Cattle train. All right, and then this will be the diesel train. So he left traveling in an effort to catch up. So we'll make him a little behind just for the sake. And we'll also make our table. And so we're gonna make the cattle train and the diesel train. Rate times time equals distance. So we'll fill out what we know easiest, like these problems have been giving us. So we know that the diesel train was traveling at 45 kilometers per hour. So we're gonna fill that out. So 45. And then we also know that 4 hours was how much the diesel train traveled. So we're gonna fill out the time slot for the diesel train, 4. Now we have to figure out, and the cattle train's average speed we don't know. So we're gonna make that X. So because we know that the diesel train went 14 hours later, we know that, let's pretend like X is gonna be the diesel train. We know that X plus 14 is gonna be whatever the cattle train, because whatever the diesel train's time is, you're gonna have to add 14 hours onto that. So then we'll plug in 4. So if 4 is X, then 4 plus 14, 18 will be the cattle train's time. So 18. And then so 18x will be the distance of the cattle train, and then 45 times 4, so 180 will be the diesel's distance. So now we know that the diesel train finally caught up. So their distances are the same because they went the same exact amount of time. So 18x equals 180. X has to equal 10 then, because you divide both sides by 18. So the cattle train's average speed was 10 kilometers per hour. All right, so why don't we do number 4? So Jose left the White House and drove towards the recycling plant at an average speed of 40 kilometers per hour. Rob left sometime later, driving in the same direction at an average speed of 48 kilometers per hour. After driving for 5 hours, Rob caught up with Jose. How long did Jose drive before Rob caught up? Okay, so why don't we draw a table as usual? We'll make this Jose, we'll make this Rob. Rate times time equals distance. So Jose's average speed is 40 kilometers per hour. Let's fill that up. And then Rob's average speed was 48. After driving 5 hours, Rob caught up. So Rob traveled 5 hours. How long did Jose drive before Rob caught up? So this question is telling us that the variable is going to be X for Jose's time. So 40X. And then 48 times 5 equals 240. So their distances are going to have to be the same, assuming that Rob caught up with Jose. So 40x equals 240. And then if you plug that into a calculator, or you can just do it mentally, either works, you'll know that x has to equal 6. So we know that since 6 is x, he's been traveling for 6 hours. You always assume that time is hours. Okay, next one. So a cargo plane flew to the maintenance facility and back. It took 1 hour less time to get there than it did to get back. The average speed on the train there was 220 miles per hour. The average speed on the way back was 200 miles per hour. How many hours did the trip there take? Okay, so this is very similar to the problem that we did, number 1. All right, so rate times time equals distance. We'll make this there, we'll make this back. So average speed to the trip there was 220. Average speed on the way back was 200. How many hours did the trip there take? All right, so we know that time for there is a question, and it took one. Now we have to figure out what the trip back, how much time that took. But it tells us it took 1 hour less time to get there than it did to get back. So we know that whatever back is, there's gonna be so if there is x, then we know that x plus 1 will be back, because it's going to take 1 hour more. So if there took 3 hours, back would take 4, hypothetically. So we'll make x plus 1 back. So now we know that the distances are the same, so we can just make them equal to each other. And for this, you'll make 200 times x plus 1. So 220 x will equal 200 times x plus 1. And then you solve it how you would solve any equation. So 220x equals 200x plus 200. And then subtract 200x from both sides. You'll get 20x equals 200. And then you know that x equals 10. Getting a lot of 10s. All right, so now we know that the trip there took 10 hours. And then for our final problem, Kali left school and traveled toward her friend's house at an average speed of 40 kilometers per hour. Matt left 1 hour later and traveled in the opposite direction with an average speed of 50 kilometers per hour. Find the number of hours Matt needs to travel before they are 400 kilometers apart. Okay, a little different, but we can figure it out. So we'll make our table. Rate times time equals distance. This will be Kali, this will be Matt. So we know that Kali's traveling at 40 kilometers per hour. We know that Matt is traveling at 50 kilometers per hour. What we also know is that Matt left 1 hour later. So if Matt is x, we know that Kali is x plus 1. So if Matt is x, we'll make Kali x plus 1. Because whatever Matt's time is, she's going to be 1 hour more. All right, so find the number of kilometers Matt needs to travel before they are 400 kilometers apart. So we're going to put a little bit of a different spin on this. So suppose this is Kali's direction, and suppose this is Matt's direction, okay? So the total distance between them is going to have to be 400. So what we know is that if we add both of their distances, if we add Kali's distance and we add Matt's distance, they should equal 400 altogether. So 400 x plus 1, and this will be 50x. So if we do 40, not 400, 40 x plus 1 plus 50x has to equal 400. All right, so now we'll solve it. 40x plus 40 plus 50x equals 400. I'm running out of room, but 90x plus 40 equals 400. 90x equals 360, x equals 4. It's really small, sorry about that. But we do know that x equals 4. So Matt's number of hours, Matt took 4 hours, and we know that Kali took 5. So find the number of hours Matt is. So the question's asking for Matt, so we answer 4 hours. So I hope that this helped you out with solving the distance problems. Thank you so much for watching. Please give this video a like and subscribe. Thank you.